You froze, Mr. Miller. Good old technology. Okay, well, Mr. Miller seems to be frozen, which means we probably look frozen to him on his end. But okay, some announcements, and also let me remember to do that. All right. The homework. Okay, remember that you are supposed to submit it as one PDF file. Not a zip file with 10 PDF files in it, but one PDF file. And you're going to get docked points if you don't submit it that way. Remember to show your work. In this class now online, more than ever, I need to see the reasons for your work, and so does Mr. Miller, okay? Put your name on your homework, on the piece of paper, all right? It was a little bit of a problem matching the homework being graded with the person doing the homework, but if you put your name on the piece of paper, it helps tremendously. And yeah, I think that's all I wanted to say about that. Mr. Miller, are you there yet? I guess not. Okay. Yeah, your homework has been graded by Mr. Miller. He and I need to talk some about it before you get it back. So yeah, you will be getting that back within the next day or so. And the solutions will be posted on Blackboard. Any questions from anybody before we get started?
Yes, just to double check, because I don't see it anywhere written. When is the first exam?
September 18th.
September 18th. Okay.
Yeah, I still don't quite know how I'm going to do it. I pretty much spent the whole Labor Day weekend agonizing over it. I don't see any good options, but I'm going to talk with people in my department and try to figure something out today.
Okay.
And I will let you know, okay? All right, anything else? Okay, let's get started. I'm going to share my screen. Okay. Please let me know if you can't see the screen. Okay, I got several questions this morning about the homework that's due this Friday, September 11th. Problems 1 through 6, I think it is. It says find the derivative using only the definition. Okay. So this is what I mean by that. We've been talking about this for the past couple of days, but here it is again. I'm going to do a few more examples. Suppose f is defined on an open interval containing the number a, then the derivative of f at a is f prime of a equal to the limit as x approaches a of f of x minus f of a over x minus a, or equivalently, f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. And well, okay, if this limit does not exist, then there is no derivative at a, and sometimes that happens. But if you have one, this is how you define it. Okay, this way or this way. And when I say using only the definition, I mean for you to compute the derivative using one of these limit definitions. So let's do we've done quite a few problems on this already. Let's do one more. Let's find the derivative of f of x equal to 1 over the square root of x plus 4. So this function has both a fraction and a radical in it. And that means we're going to have to worry about, well, both things. Okay, so using only the definition, would you rather use the x approaches a definition or the h approaches 0 definition? Somebody pick one.
How about the h approaches 0?
Okay, I'll use the h approaches 0 one. So f prime at a is the limit as h approaches 0 of f of, oops, oh, I wrote it right. Okay, good. I was thinking I did it wrong before. Okay, so I'm writing the definition first. But now it's for a particular function, this one. So that's going to be the limit as h approaches 0 of 1 over the square root of, okay, x plus 4. So I'm putting a plus h in the place of x. That's going to give me a plus h plus 4 minus 1 over the square root of a plus 4 all over h. Okay, so I'm going to deal with the fraction first. And that means getting a common denominator. And that common denominator will be, okay, so if you have a over b plus c over d, that's equal to a d plus bc over bd, okay. Algebra, that's going to be the limit, let's see, let me get rid of that. The limit as h approaches 0 of the square root of a plus h plus 4 times the square root of a plus 4 over the square root, no, under the square root of a plus 4 minus the square root of a plus h plus 4. Yeah, using this. Oh, and I still have that all over h. Okay, and now, well, I've got a complex fraction, so that's really h over 1. And if you have a complex fraction, that's equal to AD over BC. So that'll just get me down to a plain old fraction. Oops. And that's going to be then, okay, my denominator is going to be changed. New. It's going to be h times the square root of a plus h plus 4 times the square root of a plus 4, because that's b times c over here. And the numerator, still just the square root of a plus h minus the square root of a plus h plus 4. Okay. All right. So we dealt with the fraction first. Now let's deal with the square root. And square roots, we're going to use that little trick of rationalizing. Okay, so I'm going to multiply basically by 1. That's going to help me to simplify things, okay? At least in the numerator. Okay, I've got h times the square root of a plus h plus 4 times the square root of a plus 4. And I'm going to multiply by the conjugate of the numerator, which would be the square root of a plus 4 plus the square root of a plus h plus 4 over itself. So this is really just 1, but what this is going to allow me to do, yeah, it's 1 because I don't want to change the problem. But what this is going to help me with is it's going to allow me to get the square root out of the numerator, okay? Because if you have something of the form, where can I write it? A minus b times a plus b, that's equal to a squared minus b squared, because the middle term is 0. I'm going to be using that fact. Okay, so what we'll have then is the limit as h goes to 0. Well, the square root of a plus 4 times the square root of a plus 4 is just a plus 4. And the square root of a plus h plus 4 times the square root of a plus h plus 4 is just the a plus h plus 4, and that is in parentheses. Okay, so that rationalizing allowed me to get rid of the square root in the numerator. I still got the denominator. In fact, it's pretty big now. It's going to be h times the square root of a plus h plus 4 times the square root of a plus 4 times all of this stuff, okay? The square root certainly did not go away in the denominator, but we got rid of them in the numerator. Okay, so did this help us or not? Well, I've got a, let me use a different color here. I've got an a and a minus a. The a's add out, and 4 and minus 4. Remember that minus applies to everything in the parentheses. So the only thing that's left in the numerator is minus h. And okay, so now we've got the limit as h goes to 0 of minus h. Make it long because I got a big denominator. Okay, so, but now h is a factor in the top, okay, and h is a factor in the bottom. I can now cancel the h's, and that's sort of the crucial step here. Once I cancel these, oops, no. How about that first? Once I cancel the h's, my 0 over 0 problem is gone. So now have the limit as h goes to 0 of minus 1 over the square root of a plus h plus 4 times the square root of a plus 4 times the square root of a plus 4 plus the square root of a plus h plus 4. And that's equal to, okay, well, now that the 0 over 0 problem is gone, I can just use direct substitution and put 0 in for h. So gonna get -1 over that a plus h plus 4 now becomes a plus 4. And I already had an a plus 4. And then a plus 4, and this h goes, I put 0 in for that too. So wind up with, okay, well, that's the derivative right there. But I'm going to simplify it a little bit. Square root of a plus 4 times the square root of a plus 4 is just a plus 4. And okay, -1 in the, oops, no, -1 in the top over a plus 4, and then a plus 4, square root of a plus 4 plus square root of a plus 4 is 2 times the square root of a plus 4. And I guess if I could go one step further, -1 over 2 times a plus 4. Let's see, this is to the 1, and that's really to the 1/2 to the, so write it is to the 3/2. Okay. Yeah. Let me put in some details there. I've got a plus 4, and that's really to the first power, and the square root of a plus 4 is really a plus 4 to the 1/2. And so I've got a plus 4 to the first times a plus 4 to the 1/2, and the rules of algebra say that is a plus 4 to the 3/2. You add the exponents. Okay. Let me check something here just a minute. Check myself. Okay. Okay. And that's a secret way, so I'm not going to tell you. Yeah, that's right. Okay, good. Any questions? I don't hear anybody. Are you all still there?
Yeah, no questions.
Okay, good.
Yeah.
It's just a
Okay.
lot of work for that one.
That is,
That's what I was thinking.
it's a lot of work. That one's, well, okay, this one's, okay. So yeah, it's a lot of work. I agree. But this week I want you to do this kind of work. Okay. This one is fairly complicated because it's got both a square root and a fraction. And both of those must be handled. We're going to start learning some shortcuts. This week's homework, no shortcuts. Okay, so yeah, takes a lot of effort. Oh, somebody was telling me that, yeah, every day I post the notes from class on Blackboard, and I also post a link to the recordings. And there's Mr. Flores's recordings, okay? And I've got those links posted on Blackboard. Someone said that it didn't, there was no recording, but I checked it out this weekend and there is. What you have to remember, okay, is that, well, for the ones that I did, it's the second link. The first one's for just the person who recorded, the host. The second one is for the people who viewed the participants in the class. And you copy that link, but not with the passcode. The passcode it may or may not ask you for. didn't bother to ask me the other day, but it did the first time. So, okay. So that was a fairly difficult one. And we did finally get the derivative there. Let's try, okay, this is another problem. Notice we talked about the derivative being actually a way to talk about velocity, instantaneous velocity, and also slopes of tangent lines. Well, let's find some tangent lines and not just the slope. So let's take this function. F of x is equal to 3x squared minus 5x. And let's find an equation of the tangent line to the graph of f when x is equal to 2. And also when x is equal to 5/6. Okay, so if I want the tangent lines, I need the slopes for one thing. So let's take x equal to 2 to start with. We need the slope of the tangent line, which we get with the derivative. Okay, be f prime of 2. And we also need a point on the line. That's all you need. Well, the tangent line is a line. To determine a line, you need the slope of the line and you need a point on the line. And then once you have that, you can use the point slope form of the line, which says that the slope m times x minus x0 is y minus y0. Okay, so x0, y0 is a point on the line. And m is the slope. Are people in the waiting room? Okay. Let me go back. I think maybe somebody's waiting to get in. Yeah, okay. Mr. Miller, are you there? I think maybe he's having.
Yeah,
Oh,
trying
okay,
to
yeah,
get
you kind
some
of
better
froze.
more stable internet.
Right. Okay. All right. So, and now let's go back to the shared screen. And find our tangent lines. Man, maybe we'll sketch them on the graph, rough sketch at least. Okay, yeah. So a tangent line is line, and this is what's called a point slope definition of a line. How do I find a point on the line? Well, the one I want when x is equal to 2. Well, you just use a function, right? So what was the function? It's 3x squared minus 5x. So f at 2 would be, okay, that's 12, 4 times 3 minus 10, so that's 2. Okay, so 2, 2 is point on the line, the point I'm interested in at the moment. Okay, so that's going to be our x0, y0. So we have a point. We need the slope. Slope comes from the derivative. Oops. Whoops. It's f prime of 2. Okay, well, since I'm going to find two tangent lines, I'm going to get the slope in general first. Okay. F prime at A, which is going to be the slope, going to give me a formula for the slope. Let's see, I'm going to use the x approaches A definition this time. It's the limit as x approaches A of f of x minus f of A over x minus A. And that is the limit as x approaches A. Okay, let's go back and make sure I remember that function correctly. Yes, 3x squared minus 5x. And in f of A is 3a squared minus 5a. And that's all over x minus a. And that's equal to the limit as x approaches A. Well, I'm going to group terms here. Yeah, every problem is a little bit different. And what you want to do is look at it and see what you can do algebraically. Okay. Going to group the squared terms and the first x to the first and the a to the first terms. And then let's factor. Okay, so, well, let's just go ahead and put that denominator in there. Don't want to forget it. Well, first of all, I can factor a 3 out of that first term. And then I've got x squared minus a squared left. And that's x minus a times x plus a. And out of the second term, this one, just pull out 5. Okay. And then, well, x minus a is a factor on the top. Let me actually be careful about that. Use a distributive property to write x minus a. So I'm factoring x minus a out of the numerator. Whoops. It's trying to turn red. Nothing wrong with red, but stick with the blue. Okay. So if I've got an x minus a there and an x minus a there, and I can use a distributive property to write the whole numerator as x minus a times something. In particular, the something is 3 times x plus a quantity minus 5. Okay, but now I have x minus a as a factor on the top and x minus a as a factor on the bottom. So I can cancel. This time I will use the red. Okay. And Once I do that, the 0 over 0 problem is gone. And so now I've got left 3 times x plus a minus 5. And now I can use direct substitution. So that's going to be 3 times 2a minus 5, which is 6a minus 5. So f prime at a, which is going to be the slope, it's a formula for the slope of the tangent lines, 6a minus 5. And let's see, when a is 2, then m is 12 minus 5 is 7. And the line, the point we got before, point was 2, 2. Yes. So the point slope form of the line substitute in 7. Get my numbers mixed up here. 7 for m. And there's a line. If you want to write it in the y equal to mx plus b form, that's easy enough to do. Excuse me. That's equal to, let's see, so y is 7x minus 14, and then add the minus 2 to both sides. So 7x minus 12. And that's a tangent line to the curve at x equal to 2 is the line y equal to 7x minus 12. And I also asked for, well, to find it when a was 5, 6, which seems like an odd number. 5, 6. Yeah. So it's a different point, different tangent line. A equal to 5, 6. Well, what's f of 5, 6? That's, okay, 3 times 5, 6 squared minus 5 times 5, 6. Not that pretty a number. Let's see, make sure I remember my function correctly. Yeah, 3x squared minus 5x. Okay. F of 5, 6 is this number, so that's 3 times 25 over 36 minus 25 over 6, which is, okay, 3 over 36 is 1 over 12. Minus 25 over 6, which is minus 25 over 12. Because basically that's really minus 2 times 25 over 12. Okay. Okay, so the point involved here is 5/6 minus 25 twelfths, and the slope m is f prime of 5/6, which is We got a formula for f prime, 6a minus 5. Whoops. Okay. And for a, put in the 5/6, which is 5 minus 5, which is 0. So the slope is 0 here. Okay. So the tangent line then when a is 5/6 is one slope form of the line. So, and m is 0. Y minus, so it's y plus 25/12. And that says that, okay, didn't leave enough room. Well, it's a horizontal line. Y is minus 25/12. Let's draw, okay, so this is what I was going to start talking about today, but let me just go down to the bottom. Let's draw both of those lines and a kind of a quick sketch of the curve too. Okay, so we had f of x. That's a parabola. And actually, I found when the slope is 0, and it was at minus 25/12, so I'll call that minus 25/12. That's when the slope was 0. Oh, 0. Okay. And also we looked at, so call that 1, call that 2. We looked at 2 and 2 turned out to be the point on the curve. So that's, yeah, the tangent lines are at those 2 points. Okay, what's the curve? Well, it's a parabola. It goes through 0. This is very rough. Move the 2 over. Okay. Okay, so this is kind of a picture of my parabola. And we got the tangent lines. Okay, we found the tangent line here. So, okay, pretend it touches. It looks sort of like that. And it's pretty steep. Okay, and it's got positive slope. That makes sense. Because let's see, what do we get for the tangent line? 7x minus 12 is the equation of that red line. And the red line actually touches the curve. So I'll make a touch there. All right. Okay. And then we found the tangent line when a was 5/6, and it turned out to be a horizontal line. Looks like maybe when we have a low point or a high point, finding out where the derivative is equal to 0 might be helpful. So that's a rough sketch. Any questions about that problem?
I have a quick question about how we would phrase it at the end of the homework. Would we just write like tangent line of 5/6 is that, and then the other one right next to it with the graph, and then that would be an acceptable answer?
Yeah. Okay. So the tangent line to the curve at A equal to 5, 6 is y equal to minus 25 twelfths, right? It's got zero slope, it's horizontal. So it winds up having that equation. The tangent line to the curve at A equal to 2, it was y equal to, oops, oh, it suddenly changed color. 7x minus 12, was it? I can't just look back on the other side of the board to go back this way. Yeah, 7x minus 12, that's right. Yeah, so that's the way you would phrase it. Okay,
Thank you.
okay. And I hope I gave you at least one problem like that on homework. Don't remember. Okay. All right, so this is kind of where your homework ends for this week. I want to start talking about, okay, as someone pointed out, this process of computing this limit every time, it's a little long. And so we need some shortcuts. And after this week and after the first exam, we're pretty much going to be using the shortcuts. So let's start developing some of those. Here's the theorem. If f of x is c, where c is a constant, so somebody asked about f of x equal to 37. I think that's one of your homework problems. According to this theorem, f prime of that function is 0. Well, let's see why. And as I said, it's so easy, it's almost hard. Well, why is this true? We can prove it, actually. Okay, f prime of x, I'm going to use the h goes to 0 thing. That means I don't really need that. Call it a. For the other definition, one letter has to represent the numbers getting close to the number a, and a's got to be a fixed number. But now we've got h being the number that changes, so I can call the other number x. Okay, f prime of x is the limit as h goes to 0 of f of x minus, nope. Okay, sorry. Sometimes thinking and talking at the same time causes me trouble. Okay, definition. That's just the definition itself. Okay, but what is f of x plus h? F of anything is c. So f of x plus h is c, and f of x is c. In fact, this graph is a horizontal line, okay? I don't know where c is. If you got your c there, f of x equal to c is that red line. And I drew it, or c a positive number, but it could be negative too. Doesn't really matter. Okay, but here's where our definition really is important. And I remember thinking about this when I was a student, taking Calculus 1 in the 60s. Okay, I am so old. Yeah, and the thing is that c minus c is equal to 0. C minus c is equal to 0, and so we've got 0 over h. Now, I'm taking the limit as h goes to 0. So h is not equal to 0. That's key. Absolutely key. H is not equal to 0. I'm not trying to talk about 0 over 0. If h is not equal to 0, 0 over h is equal to 0. Okay. And now I'm talking about the limit of a constant. Well, the limit of a constant function is just the constant. Okay. So that's just 0. And that's all you got to do. Okay. So when you do f of x equal to 37, you're going to basically go through this little argument. But according to this, any constant function has derivative 0. And that makes sense if you think about it. Constant function has a horizontal line as a graph. The derivative, well, it's the slope is 0, right? The slope of that red line is 0. And that is the derivative. No matter where the red line is, if it's down here or up there, if it's a horizontal line, its slope is 0 and its derivative is 0. Okay, so now we have a shortcut for computing the derivative of a constant. Well, actually, I guess that's not so hard anyway. But let's look at some just polynomials. I'm going to actually do 1, 2, and 3. Oh, if I should keep an eye on the time here. We're okay. Oh, not enough. Okay. I can prove 1, 2, and 3 for you. Probably won't get to that fourth statement, although it's very similar. Okay, so this goes with prior material, so it's out of order. If you watch some of the recordings, well, it's not Oscar material, that's for sure, but you can fast forward and maybe get to where you want to see something again. So that helps. So let's see. Sorry. The screen is so sensitive. F it's easy to prove. Okay, use a definition. F prime of x. Definitions are really important in mathematics. Way to be absolutely clear about what you're talking about. So limit as h goes to 0 of f of x plus h minus f of x over h. Well, f of x is x, so f of x plus h is x plus h. And f of x is x. And then I can add out the x's. I got an x and a minus x there, so that's 0. And that simplifies my numerator. All I've got left is h over h. And h, again, h is not equal to 0 when I'm taking that limit. It's just a number close to 0. H is not 0, h over h is 1. And now it's a limit of a constant, and that's 1. Okay, so that's true. one more, and then I think we'll call it a day. Let's do the oh, sorry. Frustrating. Don't quite know how to predict what's going to happen. Okay. So here's another fact. If f of x is x squared, f prime of x is 2x. Okay, proof. Again, use the definition. The limit as x, well, let's use the a here, approaches a of f of x minus f of a over x minus a is f prime of a. So now, since I'm using the x approaches a definition, a's got to be a fixed number, and then x is represents the numbers getting close to a but not equal to it. Okay, and putting in our function, that's x, whoops, x squared minus a squared on the top there, and x squared minus a squared factors. That's what allows us to get rid of our 0 over 0 problem. Got x minus a is a factor in both the top and the bottom. And that's going to be the limit as x approaches a of just x plus a. Now I can use direct substitution and put in a for x. So that's a plus a is 2a. So f prime of a is 2a, and that's really the same thing as saying f prime of x is 2x, just calling a x. So yeah, those are easy enough. I'm going to stop there. That's enough for today. Are there any questions? Okay, well, I'm going to end class and you may leave unless you want to stick around and ask something.
I was gonna ask, are you gonna be giving feedback on the homework? Like, is there like written on our PDFs feedback?
Yes. Yes, absolutely. Mr. Miller graded your homework. Mr. Miller, are you there? Yeah, he says his internet's really acting up. Yeah, okay, this happens. Mr. Miller has graded your homework. Okay, you not need to talk about it a little bit before you get it back, but you will get it back. I think you're going to get a copy of the solutions of all of them. He graded, I think, 5 problems. Yeah, 5 problems. So you got credit for you've got 5 points credit for just doing the homework completely. Okay. And then 5 problems were graded carefully. So each of those were counted as 3 points. So 3 if it was almost perfect, if not completely correct. 2 points if something's wrong. Only 1 point if it's really substantially wrong, but there was something right about it. And you get 0 if it's completely wrong. So each homework is going to count 20 points. And that's the way it's graded. You get some credit for just doing it. And then we're going to look at particular problems, a sampling of the problems, and grade those carefully. I can't stress how important it is to do the homework every week. This is where you learn. This is where you hit the snags and you get over them and you learn the material and you get comfortable with it. It's so important. And it does count. Remember, at the end of the semester, it's going to count as an entire exam grade. So you need to do it every week. There's nothing more important that you can do. If you need more practice than just the homework allows, get your text out and look up some problems, and there are plenty of practice problems there. Okay. Any other questions?
When are your office hours again? I'm sorry.
Okay.
Right.
Well, Mondays is 10:15 to 11:15, I think. Yes. So right after my second class on Mondays, Wednesdays 1 to 2, and Fridays 11 to 12. Okay. And okay, got to make it work. Yeah. So
So
I
I
sent,
have a question for you. I'm gonna be difficult. So I'm in Orange. I tried to, I guess it was Friday, tried to do office hours with you. I tried to watch. I mean, I've been here since 8 doing this class, and I mean, I think I've had to reconnect like 9 or 10 times. So
oh God,
I learned absolutely, I can't learn anything because it's
no.
frozen
Yeah,
half the time, or I'm dropping. If I have difficulty
is this
with
Mr.
try to
Hancock?
contact, I'm having the same problem because I'm using my truck Wi-Fi.
Okay.
Yes.
Yeah, you need to, all right, you need to get a good connection. That's for sure. Uh, I agree. If you're being dropped 9 or 10 times during class, it's hard to learn. Is this Mr. Hancock talking?
Yes. Yes.
Okay, yeah, I saw you dropped out on Friday. Um, well,